Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we're looking at this idea of functions. Functions are stuff we've been looking at before. It's basically just an equation where one side is just naming what that equation is. For example, I have four different functions listed at the top here: f of x, g of x, h of x, and w of x. And we're given what those different parts are equal to. So whenever you're dealing with functions, you can do these different operations. For example, number one is telling me f plus g of x. And that notation is a little weird right now. Whenever I see notation like this, where there's an x just at the end, I always like to rewrite it so that the x is next to both the f and the g. I always rewrite it because now it's a lot more straightforward of what this actually means. Because now all I need to do is take f of x and add that with g of x. Well, I know my f of x function, which is 5x minus 2. I know that I want to add to that, and I want to add with that g of x, which is x plus 3. Well, that's pretty simple. I just replace the different letters with their respective equation or function, and then you just combine like terms in this case. 5x plus the 1x gives us 6x. Combine the negative 2 and the 3 to give us a positive 1. There is our first answer. Not every type of operation, though, is that simple. For example, if I look at number 2, it tells me now that we are subtracting. The setup is still the same. I still want to take my h equation in this case, 3x squared minus 4. And I still want to subtract after that equation, where I'm subtracting the w equation over here on the right. W is 2x minus 4. And based off of how the addition problem worked, you would think this is the correct setup. However, one thing that is very important is when you are subtracting functions, subtraction is something that affects everything. So I need to subtract the entire 2x minus 4, and that is shown using parentheses. So, okay, once we have that, then now we can go through this process. We can get rid of the parentheses by distributing the negative. When you distribute a negative, remember the signs change. The 2x is negative, the 4 is positive. The first parts just come down with it. Combine your like terms. I believe the negative 4 and 4 are the only like terms here, which actually would add to 0 and cancel out. 3x squared and negative 2x, those do not combine because those are not like terms. They have different exponents, so they do not combine. There's our answer for number 2. Number 3, same idea for that one. It is subtraction. You could go through that problem. Again, I do recommend rewriting it. When the x is purely at the end, I would rewrite it so that the x is on both. I'll let you do that problem. Number 4, though, let's look at that one. Now we're being asked to multiply instead. I have g of x times h of x. Well, g of x, look at the top again, is x plus 3. There's my multiplication, and h of x is 3x squared minus 4. And again, based off of the logic from addition, the problem looks like it's set up correctly. But when you multiply, that means everything is multiplying together. Everything in the first function, the x plus 3, needs to multiply with everything in the second function. In order to show that, you need parentheses around both. Notice there are no parentheses, or there is no sign in the middle. Then, but when there's no sign in the middle, these parentheses are just next to each other, and that is showing the multiplication. From there, we could go through our multiplication process. In order to do that, you need to separate it. We need to show x multiplying with the 3x squared minus 4. We need to show the 3 multiplying with that same set of parentheses. The first value gets distributed to multiply with both. Same idea with the 3. We're going to show it multiplying with both. So, okay, doing that multiplication now, take x, multiply it to the inside. Remember, when you multiply variables, you need to add the exponents together. Distribute another time, x times negative 4 is negative 4x. Take the 3, multiply that into its respective set of parentheses. And now we have something like this. That is our final form in this case. There are no like terms, so I can't combine anything. That would be our final answer. There is an example of how to add functions, how to subtract functions, and now how to multiply functions. Let's look at one more example that might be a little bit different. For example, if I look at these problems over here, we are now being asked to input different values. We know that if we just had something like this, f of 3, well, that tells you to plug in or input the value of 3 into the f function. Well, whenever we have multiple functions, though, we're still doing that same idea. For example, on number 12, this 3 at the end is telling me to input 3 into f and input 3 into w. So I could take those two equations. Our f equation is 5x minus 2. I could take the w equation that we're adding with it, where I see that w is 2x minus 4. We're adding them together, but we still need to follow this process that says plug in or evaluate this value of 3. So I plug in 3 to these different parts. From there, you could go ahead and utilize Desmos or your calculator, because this is just values, and you'd get a number or a value out of 15. That problem is complete. Let's look at number 14 as well. I think that's also a good example. We take our g function and our f function, and we multiply them. Our g function is x plus 3. Remember, to show multiplication, we use parentheses on both. And that multiplies with f, which is 5x minus 2. But on this one, we weren't just multiplying these functions, we were also evaluating. We were plugging in these different values. That means that we can now plug in the negative 6 to the g equation. That means the x changes to negative 6. The second equation, we're evaluating or plugging in a value of 2. Notice the x changes for that one as well. From there, you could type that into Desmos, simplify it, whatever you need to do. This one comes out to a value of negative 24 if you were to multiply all of that together. Again, you can just use your calculator. So there's some examples of adding, subtracting, multiplying, and evaluating. We could make these problems more challenging and do multiple operations at the same time. We'll look at more of that when I return. However, let's get into the second part of this. At our level, the new thing that we're learning is what's called function composition. Or composition of functions. Well, function composition means that you are plugging in a function into a function. And that might sound kind of weird, so let's break that down. Let's say that we want to evaluate a function. Let's say I want to take the g of x equation that's shown over here, which is x minus 4. And let's say I just want to evaluate that or plug in a value of 3. Well, all that you would do there is just replace the x with that value. And then simplify. Well, we're doing the exact same thing, but on another level, where you're not just replacing x with a value, but you're now replacing x with an actual function. Let's look at number 16 to show what I actually mean. Function composition is notated in two ways. You might notate it with this little O right here, this little open circle. That means of. However, I don't like that notation. I like to rewrite it. I always change that notation to look like this. W parentheses h of x. Because this notation tells me what to do. It tells me that I'm going to take my w equation, the outside equation, which is 3x minus 1, and it's telling me that, okay, instead of x on the inside, it's telling me that x now changes to h of x. Okay, but if I'm changing x, that means I need to change all of the x's to that function, to h of x. So, okay, I'm in this function still, 3x minus 1, but we said we're changing the x. We're replacing it. We're plugging in this function. Just like I would replace x with a value, I'm replacing it now with this function. Well, that's the basic idea of it, but okay, that's not quite done yet. I need to simplify that. Well, we know what h of x is. H of x is this function here. So instead of leaving it as h of x, I can replace it with what it's equal to. And then from there, we could simplify. We could distribute and combine our like terms. And now that problem would be done. Let's go ahead. Let's look at one more of those as well while we are at it. Let's go ahead. Let's look at number 17 as well for this purpose. Again, if you have that little o, that doesn't mean multiply, that means of. Change its notation to be with parentheses on more parentheses. G with w of x on the inside. Well, same process starts then. You always start with the outside function. That's g of x. G of x is just x minus 4. Okay, but we didn't want g of x. We wanted g of w of x. That means instead of x, I am now plugging in whatever w of x is. So x now gets changed to be w of x. The minus 4 is still there. But okay, we know something about w of x. W of x is 3x minus 1. Make sure you plug it in and simplify. In this case, there's nothing to distribute into the parentheses, so you could get rid of them. Combine your like terms as well, and now you have your final answer. That's what we get for number 17. 21, 22, 23, similar ideas. Those are just telling you to plug in different things. You can always start with the outside function, f, which is negative 2x. You could plug in g into that. So now I could replace whatever x is with our g function. But we didn't want f of g of x. We wanted f of g of 2. So that means I need to replace the x with a value of 2. Simplify that and find out what it gives us. If you were to do that, type that into Desmos, it looks like that should give you a value of 4. That is our 6.1 lesson, all about functions and different operations. Thanks for watching.